Let's take a look at a series of questions that are related. The average annual salary for all U.S. teachers is $47,750. Assume the distribution is normal and the standard deviation is $5,680. Find the probability that a randomly selected teacher earns between $35,000 and $45,000 per year. So we'll start out with our graph. $47,750 here in the middle. I'm looking at between $35,000 and $45,000. But let's label stuff. So here's our mean. 5680 is our standard deviation. And we want between 35,000 and 45,000. I'm going to use the letter K to indicate thousand. We use K because in a metric system, the prefix kilo means 1,000. So a kilogram is 1,000. A kilometer or kilometer is 1,000 meters. So sometimes instead of writing out the 3 zeros, we use the letter K. It means the same thing. So here I want to know the probability of a teacher earning between $35,000 and $45,000. So I need to do a subtraction. I need to first find the probability for less than $45,000 and subtract from that less than $35,000. So I need to subtract off the piece on the left, less than $35,000. So we'll put in our calculation, norm.dist, x is 45,000, our mean, our standard deviation, and true, minus another norm.dist, and this time we're going to use 35,000 for x, and everything else stays the same. 47,750, 5680, and true again. So we'll do 45,000, 47,750 is our mean, 5680 is our standard deviation, and true. That gets us the probability less than 45,000, but I want between 35,000 and 45,000, so I need to subtract off norm.dist 35,000 mean, standard deviation, and true, and we get about 30.2%. Now we want to see what's the probability a randomly selected teacher earns more than $40,000 per year. More than $40,000 per year. Draw our graph again. More than means we're going greater than 40,000. Looking at this graph, I know my answer has to be bigger than 50% because 50% is already taken care of to the right of my mean. So I know my answer needs to be bigger than 50%. Also, I'm looking for area greater than, area to the right. So for area to the right, we have to put 1 minus our norm.dist because the norm distribution function in technology gives us area to the left. We want area to the right, so we're going to subtract off the area from the left. So we'll have 40,000, mean, standard deviation stay the same, and true again. So let's put that in. 1 minus norm.dist, 40,000. Don't put a comma in there. Excel doesn't like commas for numbers. Commas in Excel are separating arguments in the function. Our mean, our standard deviation, and then always true. And we get 0.9137, 0.914, or 91.4% that a randomly selected teacher is going to earn more than $40,000. And this makes sense. 50% will earn $47,750 or more, so we're going to pick up a little more with that 40,000 going below that. All right, and our last question in the series, if you were applying for a teaching position and were offered $31,000 per year, how would you feel? Would you consider the job? Now, this is a question that not only applies to teachers, but it can apply to you when you go out into the world and look for your own job. How does your salary that you're being offered compared to other salaries in the same field? How does it compare to other salaries of the same field in the same region? Because we know that regionally our cost of living could be different. So let's see how we could approach this statistically. We could look at this in two different ways. We could figure out what is the probability that a teacher earns $31,000 or less, or we could flip it around. What is the probability that a teacher would earn $31,000 or more? So we could see what percentage of teachers are going to be paid less than us, or what percentage of teachers are going to be paid more than us. Those two numbers are going to add up to 1, so it doesn't really matter which one we do. Less than is usually easier, so we can calculate that. So here's my mean, 47,750. 31,000 is going to be somewhere to the left, and let's calculate to the left. So probability x is less than 31,000 is just a straight norm.dist function. So we'll put in 31,000, our mean, our standard deviation, and true. And we get 0.0015. So 0.002, which would end up being 0.2% of teachers would make less than you if you took that job. That seems extremely low, but that's something to consider. Maybe it's a very rural area and they don't have a lot of money and it's really cheap to live there. You'd have to think about it and make a decision. One more example left in this section on new home prices. If the average price of a new one-family home is $246,300 with a standard deviation of 15,000, find the minimum and maximum prices of the houses that a contractor will build to satisfy the middle 80% of the market. Assume the value is normally distributed. Okay, this takes a little bit more work. This is not as straightforward as the questions we've been doing. So let's identify the pieces that we need, and then we'll head on over to Google to get us some help. So first, average price, $246,300, there's our mean. Standard deviation, 15,000. We want to find the minimum and maximum prices of the houses that a contractor will build to satisfy the middle 80% of the market. So this middle 80%, that's a probability or an area. And it's the middle 80%. So let's draw this out. Our mean, 246,300 in the middle. And the middle 80% is going to be in the middle, but that means that there's a cutoff on the left and on the right. And the cutoff parts have to equal 20%. Well, since it's the middle 80%, I want half on each side. So I have 10% on the left and 10% on the right. So we are looking for these numbers here. So far, all the problems we've been doing have been using the norm.dist function, which give us back probabilities. But this problem wants x values, not probabilities. We are given probabilities in a way. In this left number, we have 10% to the left. So for the minimum value, I'm going to use the norm.inv function, the inverse function. Since I'm looking for an x value, I want the inverse function. And my area to the left is 0.10, 10%, which is 0.1. So I'll put that in. We'll put our mean, 246,300, and we'll put our standard deviation, 15,000. And that's all we need for the inverse function. So the inverse function takes the probability to the left of the number that I'm looking for. Okay, let's get that answer. Norm.inv. My x is the probability, or the area to the left, 0.1. Our mean, 246,300, and our standard deviation, 15,000. And we get 227,000 $76.73. So we can put that in there. $227,076.73. To find the maximum, we need to find the area to the left of the maximum. Now the area to the left isn't 80%, it's 90%. So we want to make sure that when we find the maximum, we're putting in 0.9 for our probability to the left. So let's write this out. Maximum will be norm.inv 0.9 to 46,315,000. And let's see what Google will give us back. 90%. And we get $265,523.27. So our minimum value, $227,076. Our maximum value, $265,523. Those would be the values of the houses that the contractor would want to build to satisfy the middle 80%. In the OneNote, I'm going to take these formulas that you see for our inverse and our distribution functions, and I'll paste the images in the OneNote so that you can go back and take a look at them and maybe compare to your own work as you work through these problems. If you make a mistake, you can see hopefully where that mistake is and learn from it. And there you have a good range of examples for using the normal distribution to calculate probabilities and to find x values that correspond to probabilities. Keep in mind the difference between the distribution function and the inverse function. The distribution function, like up here with the teacher salaries, these are giving us back probabilities, proportions, areas, percentages. But down here in the new home prices, the inverse function is giving us back x values. We would never do a 1 minus norm inverse function because the inverse function is working along that x-axis line. Keep practicing with them.